once went to the moon in peace for all mankind. But today, the twin sister of Apollo has awakened. Artemis does not seek a flag or a footprint. She seeks a home. We are no longer just visiting. Between 1968 and 1972, the United States launched 9 crewed missions to the moon, resulting in 6 successful landings and 12 individuals walking on the lunar surface. Today, NASA is beginning its next phase of lunar exploration, known as Artemis. The goal of this program is to establish a permanent human presence on and around the moon while utilizing these missions to practice the complex operations required for future human travel to Mars. The journey began with the assembly of the Orion spacecraft, which took place over several years within the Neil Armstrong Operations and Checkout Building. Technicians painstakingly welded the aluminum structure together and outfitted the capsule with thousands of individual components. To launch these heavy payloads, NASA has developed the Space Launch System, SLS. This rocket consists of 2 solid rocket boosters, a massive core stage, an exploration upper stage, and a cargo area. The SLS is the most powerful rocket ever built, surpassing the Apollo era's Saturn V.
You have a go to proceed with terminal count and launch of Artemis I.
Or go for launch.
Go for launch.
Said weather is go for launch.
For the Artemis generation, this is for you. At this time, I give you a go to resume count and launch Artemis I.
While Orion spent several weeks circumnavigating the moon, it traveled further from Earth than any previous human-rated spacecraft, reaching a distance of roughly 268,000 miles. The mission marked a transition from the Apollo generation to the Artemis generation, intended to foster new discoveries for the benefit of all. As it returned to Earth, the spacecraft endured searing temperatures of 5,000 degrees Fahrenheit during atmospheric re-entry. A complex system of 11 parachutes deployed to slow the capsule from 300 miles per hour to a manageable 20 miles per hour for splashdown in the Pacific Ocean. Following the successful recovery by a joint team from NASA and the Department of Defense, Orion was towed into the well deck of a Navy ship and transported back to San Diego. This successful shakedown mission exceeded all expectations and provided vital data to improve safety for future missions that would eventually carry astronauts back to the lunar surface.
Good afternoon from the Space Coast of Florida, where 4 astronauts are about to suit up for NASA's boldest test flight in a generation.
Artemis II served as the first crewed lunar mission in over half a century, carrying 4 astronauts around the moon to prepare for a long-term human presence for science and exploration. This 10-day test flight demonstrated deep space capabilities and proved the Orion spacecraft could sustain life while allowing ground teams to practice essential operations. On launch day, the crew suited up at NASA's Kennedy Space Center and traveled to Launch Pad 39B, where the 322-foot-tall Space Launch System awaited after its journey from the Vehicle Assembly Building. The launch team filled the propellant tanks with over 700,000 gallons of liquid oxygen and hydrogen, verifying all systems before the 4 RS-25 engines ignited to begin the journey. Just like Artemis I, once in high Earth orbit, Orion separated from the upper stage and used the expended hardware as a target for a proximity operations demonstration to practice manual piloting. After verifying life support and navigation performance, the service module performed a translunar injection burn, pushing the spacecraft on a 4-day trip toward the Moon. The astronauts traveled approximately 4,600 miles beyond the Moon, making them the first humans to see the lunar far side in over 50 years. Following a brief communication blackout, Earth's gravity drew the spacecraft back home on a fuel-efficient free return trajectory. Before re-entry, the Orion crew module separated from the service module and oriented itself for atmospheric entry. The capsule hit the atmosphere at nearly 25,000 miles per hour, subjecting the crew to forces 4 times the weight of gravity while the heat shield endured temperatures of 5,000 degrees Fahrenheit. A precise sequence of 11 parachutes deployed to slow the craft down, eventually reducing its speed to less than 20 miles per hour. After traveling more than 595,000 nautical miles, Orion splashed down in the Pacific Ocean only 16 minutes after entering the atmosphere. A recovery team from the U.S. Navy, Air Force, and NASA secured the capsule and flew the astronauts to a recovery ship, successfully completing the 10-day mission. The Artemis II mission provided humanity with a perspective on the Moon that had not been seen in over half a century. Using high-resolution topographic maps and advanced lighting data from the Lunar Reconnaissance Orbiter, NASA's visualization experts crafted a photorealistic preview of what the 4-person crew experienced from their cabin windows. Unlike the Apollo missions of the past, which had orbited just 60 to 70 miles above the surface, Artemis II performed a high-altitude flyby, soaring nearly 5,000 miles above the lunar crust. From that incredible vantage point, the Moon appeared to the astronauts as a massive sphere the size of a basketball held at arm's length, allowing them to view the entire lunar disk, including the North and South Poles, all at once. One of the most profound moments of the 10-day journey was the transit across the lunar far side. During the Apollo era, missions were timed so that the near side was in daylight for landings, which often left the far side draped in shadow during flyovers. However, depending on the specific launch window, the Artemis II crew became the first humans to see the rugged, crater-scarred far side fully illuminated by the sun. By studying those visualizations, the crew memorized landmarks and prepared for the breathtaking Earthrise that signaled their return home. The mission acted as a definitive bridge to a sustainable future on the Moon, turning decades of data into a lived human experience. A major difference between the Artemis and Apollo programs is the strategy of pre-staging. Instead of carrying everything on one craft, international and commercial partners will deliver rovers, science equipment, and landing systems to the lunar environment in advance. A key part of this infrastructure is the Gateway, a dedicated space station orbiting the Moon. The Gateway served several critical roles. It functioned as a sustainable hub for communication relays and landing systems, provided increased accessibility by adjusting its orbit to reach any part of the Moon, and acted as a proving ground for the complex maneuvers required for future Mars missions. As the crew arrives at the Moon, Orion docks with the Gateway. While some astronauts remain on the station, others transition to a lunar lander. The landing process involves 3 steps: dropping from the halo orbit to a low lunar orbit, descending to the surface, and eventually launching back up to the Gateway. When the mission is finished, the crew returns to Orion and departs the Gateway. 2 engine burns propel the craft around the Moon and back toward Earth. Each successful Artemis mission brings humanity one step closer to proving we are ready to explore the vastness beyond. For years, the world looked to Artemis III as the historic moment humanity would finally return to the lunar surface. However, as of February 27, 2026, NASA officially revised the mission profile due to ongoing delays in lunar lander development and concerns regarding the Orion spacecraft's heat shield. Originally intended to land the first woman and person of color at the Moon's South Pole, Artemis III is now slated as a crewed test flight in low Earth orbit, currently targeted for late 2027. This strategic shift mimics the 1969 Apollo 9 mission, focusing on proving that the complex docking maneuvers required for deep space exploration can work safely before we commit to the long journey back to the Moon. The primary focus of the revised Artemis III mission is the high-stakes testing of the Human Landing Systems, HLS. Astronauts will perform historic rendezvous and docking operations with SpaceX's Starship HLS and potentially Blue Origin's Blue Moon lander in Earth orbit. This race to readiness is crucial. Whichever vendor successfully demonstrates interoperability during Artemis III will likely secure the lead for the actual lunar landing now scheduled for Artemis IV in 2028.